Okay, good evening, students. Here we discussed about introduction to IoT and then discussed about Arduino programming. So initially, you should know what is IoT, Internet of Things. So the idea is that we can now you know that you can access to the many resources through the internet. So idea behind this IoT is that you can manage, you can control, or you can exchange many devices that are accessed through the internet. So that is basically IoT. So as given here, IoT is the interconnection of physical devices through the internet, enabling them to collect, exchange, and process data automatically. So as you know, there are many devices. Devices can be sensors, so any devices that can be accessed through the internet, basically IoT. As an example, now you know that through the mobile phone, you can access to your CCTV system in your home, or from your mobile phones through the internet, you can switch on and off some of the devices at home. So basically, you can do many things through the internet. That's basically idea behind the IoT. So with compared to old days, now we can connect any sensors or any smart devices through the internet. So basically, you can connect some home appliance like the let's say if you want to switch off on some of the devices at home through your mobile phone can be done, and some of the medical equipment uh, like if there's a patient, you can automatically monitor the condition of the patient through your mobile phone. So like you can do many things through the your mobile devices, and through the internet you can do this task. Especially nowadays, we speaking about this smart city, smart agriculture, or smart devices. Like those are the key components in the IoT. So these are the devices actually I use in smart watch, smart TV, smart refrigerator, smart door lock, smart lights, smart thermostat, smart car, smart autometer. Like many things can be managed through your devices. Basically, that's the basic idea behind this IoT. Through the internet, you can access to these devices, and you can monitor many things. Some instance in your refrigerators through your mobile phone, you can on and off some of the parts, and you can see what items are available through your mobile phone that are available in the refrigerator. Like the things can be automated and can be managed in a single device. From the internet you can access to these devices. That's the idea behind IoT. So here basic components of the IoT is actually, now here basic things are things. What is mean by this internet of things? The things can be a smart watch, a smart bulb, a smart camera, a smart refrigerator, smart car, like that. So those devices may have some sensors. Basically through the sensors you can get some inputs, you can get some values, and then there will be some other activators. Through that you can send some commands to make the activations. As an example, let's say based on the temperature you want to execute the fan. So when the temperature is low, it will be off. When the temperature is high, it will be on. So this can be automated through your devices, and which can be controlled through your mobile phones, so through the internet. And the other components in the IoT are sensors. We use different sensors that are available in the environment. Normally we have temperature sensor, humidity sensor, motion sensor, or light sensor, pressure sensor. Like there are many sensors, through that you can get some environment conditions. So that is another key component of this IoT. We have a lot of sensors. You know the sensors are very small devices, but we can get more information or more values or more data you can collect through the sensors. So that's the second component of the IoT. Then the other one is actuators. Based on the sensor inputs, you can connect this input to a microcontroller and which can process it and make a decision. Accordingly, you can generate some actions. So to activate these actions, we have the activators, maybe a motor, maybe a fan, maybe water pump or electric lock or robotic arms. Like there are different parts connected and we can send some commands to these activators to activate. As I give the example previously, you have the temperature sensor which will get the current temperature in the environment. Accordingly, you can switch on and off a fan. So we have a practical in here called as auto fan. So we can develop that kind of device using the microcontroller. So that is an example for the activators. And there will be processing unit. Now in this case, we use a microcontroller. We are discussing about this Arduino Uno microcontroller. So or we can have embedded computers or Raspberry Pi or ESP32. Like we can use different processors. So basically in this IoT, we are using the microcontroller. So through that you can process and make some decisions or make some actions accordingly. So we discuss about the microcontroller in details later. So this CPU or this processor will receive some sensor data and then process that information and make some decision. Accordingly, it can generate some commands or send some commands to the activators. And again, we need to have the communication networks for these devices actually because we are going to manage some of the activities through the internet. So in that case, we need to have some kind of technologies to make the communication either Wi-Fi or Bluetooth or CB, NFC, Ethernet, LoRa. Like one of these technologies should be used to make the communication between those devices through the internet. So then we have a practical. We discussed what devices should be used to make that connections through the wired cable or wireless cables. You can use that communication. And again, some of the processing cannot be done by this microcontroller. As you know, this microcontroller is a very small device, very slow device, and less power consumed. In that case, to process some data that are collected, we need to use a cloud resources. As you know, cloud is all the resources available in the internet, and you can access to those resources through the internet from anywhere at any time. And again, the cloud, we know that concept is to share the resources without buying the resources. So then remember through the cloud, you can access to the cloud and you can do many processing through that actually. So basically cloud is necessary to process some of the collected data because large data cannot be processed by the microcontroller. The microcontroller is a very small computer which is very slow and very less memory. So in that case, to manage or to process large amount of data, we need to send our data to a cloud, and through the cloud resources, you can process it, and then you can get the results back to the control and make some decision. So then we have to use this AWS IoT cloud or Microsoft Azure or Google Cloud. Like we can use these cloud resources to complete the processing of large data. So always keep in mind, we cannot do the processing in the microcontroller, which is very slow and again very small one. And again, there will be some user interfaces for this IoT, maybe through the web mobile apps or some web data dashboards or some smart display should be used to monitor what's going on this IoT. So one of the key characteristics of the IoT, remember it is internet connectivity is necessary. Otherwise you can't do anything. And again, normally they are real-time computations. Like we get the real-time data, like through your mobile phone, you can access to your real-time CCTV systems and monitor what's going on. So like they are real time. And automatic operations, most of the time they works based on the sensors and automatically make the reactions. Like as I told you, based on the temperature, the fan can be activated or AC can be activated. So they are done automatically without using involvement. Therefore, most of the activities are automated, and some of the data collections can be done. Sorry, before, because you are using many sensors here actually. Through the sensors, you can get many of the data, and you can make some decisions. And most of the time remote monitoring, because as you know, through your mobile phone you can access to your home and you can switch on and off some of the devices, or you can check whether your home is locked properly. Like you can make that kind of things remotely, and you can make some intelligent decision making. As you know, we can transfer this data to our intelligent systems in the cloud and make some decisions, and we can make the device to device communication without human involvement. All these real sensors and other devices can be communicated, and which can be a very large scale, because through the internet or through the cloud you can do many things. And all these devices are very slow actually. When you take this microcontroller, they are very slow and very small, and power consumption is very low in the IoT devices. These are few of the examples. Application of the IoT in the smart home. That means through your mobile phone, you can switch on and off the lights, and you can check whether the locks are working properly. And you can access to your CCTV camera systems from your mobile phone, or you can access to the speakers, or you can manage the air conditioners. Like these are some of the examples of IoT applications. Because of the IoT, you can make save the energy. That means through your mobile phone, you can switch on and off your AC, and which is very convenient. You are, maybe you are in outside, or you are maybe in another country, but you can access to your home through the internet, and you can provide more security, because through the internet you can see your CCC systems. Like more security can be implemented. This is one example of IoTs in the smart home. And smart healthcare, where you can monitor the health automatically. You have some sensors which will detect your some of the details about health conditions, how much distance you have walked. Like you can get many information through your sensors that are there in your devices. So which can be done remotely actually, when you are not at home, but you can monitor. If there's a patient at home, you can monitor everything, every conditions without that person knowing. You can monitor through these applications that are developed with the IoT. And based on the sugar level, you can have these insulin pumps, so which can be control your insulin or sugar levels, which can be done in automatically through the systems. Like those are some applications of the IoT, the smart healthcare. So because of that, you can have better healthcare, and you can early detection of the diseases, and remotely you can make the consultations. At the same time, in agriculture, you can monitor the conditions of your greenhouse, the soil moisture conditions, and automatic irrigations or weather monitoring. Based on that, you can make some reactions and livestock managing. So, like those can be done through the online systems, or remotely you can do this. So, because of that, you can increase the crops and reduce the water usages and improve the farm management. These things can be done with the IoT. And smart city, which is one of the new area nowadays, smart traffic light systems, smart parking, and waste management, air quality monitoring, street lighting. So those things can be automated, and again can be managed through automated systems. Because of that, some traffics can be minimized, congestion can be minimized, better public services, so improve the environment. Like many things can be done with these applications. So these are some of the advantages. Basically, automation of the routine tasks, improve the efficiency, real-time monitoring, remote control of the devices, better decision making through the data, reduce operation cost, increase the productivity, improve the safety and security, better customer experiences. Like many advantages are there because of this IoT. However, there are some disadvantages. So sometimes these privacy concerns, because as you know, these sensors are working on microcontrollers that are very slow and it is small things. There can be some data losing because of the sensors. So privacy concerns, some cybersecurity attacks can be occurred. And again, the cost may be, initial cost may be higher, and everything will depends on the internet connectivity. Sometimes the compatibility issues when you're going to make the connections in the multiple devices through the internet, and maintenance can be complex. And sometimes you get large amount of data which is difficult to manage. Uh, so like you can see these disadvantages also will be there when you're going to work with the IoT. Now, one of the key things we have in the syllabus before you are going to discuss about the IoT is critically now the embedded systems. Actually, embedded systems idea is that within a application or systems we have a special purpose computer which will be built inside the other machines, so that which will take some actions and process. As an example, your, let's say, our device example is a washing machine. Now the washing machine, you can see there are some buttons through that you can make some processing. So in that case, there is a small embedded systems in the washing machines where you can give some inputs, accordingly it can process and give you the. So that is basically the embedded systems actually. Or if you take a car, so we know that in the car, in the dashboard, you can see some indicators. When the fuel is not enough, that will be indicated. If there's an engine error, that will be indicated. So then that there should be a kind of hardware with the software which is processing actually. In the car, actually, it gets all this information through the sensors, and that will be displayed to you through the dashboard. So that is a kind of embedded systems. So then basically in the embedded system, you must have the microcontroller or sometimes microprocessor, a small chip, and memory. RAM and ROM should be there. Some input devices or sensors mainly, and output devices or sometimes activators, and some software or the firmware should be there to manage those applications. These are the key components of the embedded systems. As an example, we can create embedded systems through the microcontroller. You measure the temperature through the sensors, and based on that, you can activate the pan actually. We'll do this practical or this application development through the microcontroller, through the Arduino board. We'll discuss that one later actually. So then basically what are the characteristics of the embedded systems? They are designed for a specific task. As an example, washing machine, or as an example, traffic light systems, or as an example, the car. So they are very reliable and efficient, very small in size, low power consumptions. They work with real-time data. Probably they have very small memory and the very small processor in the power consumptions. Not like a general purpose computer like laptop, desktop. These are the examples for the embedded systems like washing machine, microwave oven, digital camera, smart TV, printers, traffic light systems, ABS systems in the car, smartwatch, medical devices. Like these are basically some embedded systems. The idea is that we have a device or machine, but this machine has a small computer. So that is we call as embedded computers. What are the advantages is that they are very fast and efficient for that specific task. They don't do multiple tasks actually. In our computers, we do the multitasking, but probably these devices are developed only for a specific single task. And they have very small processor, therefore power consumption is very low and compact and very small, very reliable. Disadvantage is it perform only specific tasks. You can't do the multitasking. And it is difficult to make some changes or updations, and limited hardware resources are there. So this is basically comparison between general purpose computer and embedded systems. Now we know in our computer you perform many tasks. Usually can install the many applications like laptop, desktop, and computers. But embedded systems perform only one specific task, and the software is specific or fixed for its dedicated purpose, like washing machine, micro ovens, car ABS systems like that. So that is a basic comparison between the embedded computers or embedded systems and our general purpose computers. Okay, now we come to the very important part is a microcontroller. So the microcontroller is actually the difference. You should know what is the difference between the microprocessor and the microcontroller. So in our computer, we have the microprocessor actually, or CPU. It's a single chip. But remember the microcontroller, normally very small, very slow, and less power consumed, single task executing a device. The difference is actually microprocessors are very fast, which can do multiple tasks. It's a separate CPU. Separate memory, I/O devices, and RAM can be connected separately, and you can change the sizes of the memory, or you can change the, if let's say the memory is not enough, you can increase the memory size. So you can increase the hard disk, or many I/O ports are there. But when you take the microcontroller, all line together actually, the processor, memory, and the I/O ports are all are together in a one single chip. It's because of that you can't increase the memory size. You can't change the memory size because all are inside this chip. So here we have this microcontroller. That is, there are many kind microcontroller. This diagram is actually one of the organization which manufacture this microcontroller is Arduino. This Arduino board actually. Now we'll discuss about these parts later one by one. So here you can see the difference between the microprocessor and the microcontroller. Microprocessor is the one we have familiar with. Normally our computer or general purpose computer is microprocessor. Inside we have the CPU basically over a single chip. Inside we have the ALU, CU, controlling registers. Those are the parts. But microcontrol is different because inside you have the CPU chip and the RAM, ROM, other counters and the timers, everything is together as a single chip. And we have the ports connected for the address data and the controls. So these bus systems can be connected. Now remember in the microcontroller, you can't increase the memory size because all are inside a single chip. So then that's a comparison between the microprocessor and the microcontroller. Just keep in mind in the microcontroller, not only the CPU, RAM, ROM, other parts are in a single chip. Because of that, you can't make some changes to the microcontroller where it is allocated only for single task. But microprocessor is kind of multitasking machine which is very fast. So what are the main components on this microcontroller? We have a CPU or a main processor is there actually, which will execute and control the instructions and perform some arithmetic operations, make some logical decisions. So just like a normal CPU, microcontroller also have a processor or CPU. And again, it has its own ROM or flash memory, which can be programmed, which is non-volatile. Time to time, you can program just like a pen drive. And it has a RAM also. So inside this microcontroller chip, there's a RAM. We know RAM is kind of temporary memory, volatile memory. Once you get the sensor values, others you can temporarily stored inside the RAM that is there in the microcontroller. And there is electrically erasable programmable ROM. That means you have some memory which you can program, like to keep the password, device settings. Those values can be stored inside this EEPROM that is there inside the microcontroller. And it has some input output ports actually. So we have some input ports where you can get some input to the sensors like temperature sensor, light sensor, gas sensor, motion sensor. Like with the sensors, you can get some inputs. At the same time, we have the outputs. If let's say you want to on LED or LCD or buzzer or motor you want to start, for that you have to have the outputs. So like we have the input output ports in this controller. We'll see them and then identify those one by one. And we have some timers and counters because we want to measure the time and count pulsive modulations, generations, or frequency measurements. For that, we have the timers and the counters are there, which will generate the timing values. And there will be some converters, analog to digital converters, because once you get some analog inputs, we want to convert them to digital values, so that we have to use the ADC, analog digital converters. Like when you are getting some temperature sensor, light sensor values, those are analog values, we may need to convert them to digital values. At the same time, have the digital to analog converters. Once you the digital things, we want to convert them into analog. Like for the audio systems, we want to convert these signals into the analog from digital state. And there will be some communication interfaces because we want to communicate with these devices that are there in the controllers using the different technologies like GPS, Bluetooth can be used. Or we have the communication interface in your device, actually serial peripheral interface, which is for very fast communication like SD cards, LCD display, sensors. We can use this SPI, a serial peripheral interface can be used for the communication. And I2C is an integrated circuit which also using two wires to make the communications, and USB also can be used make the communication to transfer some files or programs from your laptops to the microcontroller. You can use USB communication. Like there are many communication parts that can be used to make the communication between the microcontroller and the other devices. So main advantage of this microcontroller is we know it's very small and compact, low power consumption, very low cost actually, reliable, fast, and ideal for embedded systems. It has very limited memory. You can't have very large memory because they are inbuilt. You can't change the memory sizes. And processing power also very limited. So they are you can use only for single tasks. So which cannot be used for multiple tasking. It is difficult to upgrade the hardware. So then we want to discuss about one of the key thing here is Arduino. Remember this Arduino is an organization. They manufacture this open source electric platform and hardware and software which you can use for some development where a single task can be implemented. So then, which is a very popular one actually for embedded systems, robotics and IoT. We use this Arduino platform to make some experiment. So basically it is open source. That means you can view the codes and very easy to program, very low cost. It works with the multiple platforms. So there is a community supporting for this, and it is expandable and support IoT and real-time processing. So many applications we use this Arduino when are developing some robotics arm, smart home, Islam agriculture, like previously discussed about those devices where you can use this Arduino. Now let's see some parts of this Arduino Uno board. These things you should know in the exams. They have asked some questions related to this actually. So another key thing is a USB port. So here you can see we have USB port. This one actually, here is a USB port. Through that, once you write the programs in your computer, you can upload your computer programs to the Arduino boards using the USB cable. You can connect your computer and the Arduino board using the USB port. So using that as given here, we can connect the computers, basically upload the programs from your computer to the Arduino, as well as this can provide the 5-volt power, DC power can be sent to the microcontroller or the Arduino board. Power can be provided, and you can have the serial communications. So that is the one of the key part of the Arduino board. And then the 80 mega 328p controller or microprocessor. That is the main key component actually in the microcontroller. That is this one. So this part is actually the microprocessor or microcontroller. So that is the one which will execute and process your sensor inputs. So normally it is very slow processor. Actually, it's 8-bit. You can see 8-bit processor. Speed is 16 megahertz. This much of flash memory, this much of SRAM, this much of EEPROM. So like you can see, it's a very small processor. That is what we call microcontroller that is there inside the Arduino Uno board. Then you have the DC power jack. If we want to provide the power directly to this external, we can use this power jack that is available here. This one, DC power jack. We can have the power input from 7 volt to 12 volt. Power can be provided because sometimes we want to have more power. In that case, you can provide external power through this DC power jack. And voltage regulator is there. Why do you want that one? Actually, we want to regulate the voltage values. Yeah, we want to protect our device. For that, actually, we can use this voltage regulator defined here, this one. So whenever you get higher voltage, if you want to convert into 5 volt, we have to use this one, which will protect your microcontroller from fluctuation of the voltage levels. Can be managed to make your device protect your microcontroller. We can use this voltage regulators. And in here, actually, we have digital inputs, output. So you can see the Arduino Uno board. There are 14 digital I/O ports. Through that, we can have this digital inputs and outputs. So this part, actually, this here you can see. Here there are 14 in this part. Here there are connections or pins. Through that, you can input some data as well as you can output digital inputs and outputs. D0 to D13 will be used for digital inputs and outputs. We want to get some inputs, digital inputs, or read some inputs you can use, and again you can outputs. Maybe you want to on the LED, or you want to use a buffer relay digital sensors. Like you, for that actually you can use this digital input output. There are 14 digital I/O pins. And we have this PWM pins. PWM means pulse width modulation. Basically, you want to have different values actually. This pin number 3, 5, 6, 9, 10, 11 can be used for this one actually. Where let's say in the LED, we want to change the brightness, or you want to change the speed of the DC motor. So in that case, you want to generate different speeds with that different voltages with this pulse width modulations. Is one of the example. For that, you can use this analog write function to write the values and change the maybe you want to change the LED brightness. Maybe you want to run the DC motor very fast or reduce the speed. Like for that, you can use this inputs pins. At the same time, there are analog inputs actually. Now, previously we have the digital inputs and outputs, but there are some analog inputs pin because we have to get only inputs like through the sensors. Through the sensors like temperature sensor or light dependent registers or gas sensor, like through the sensors, you want to get some analog inputs. To get that one, we have the 6 analog input pins here. This one actually. In this point, you can see there are 6 analog pins. Through that you can get some sensor inputs. So the sensors, you want to read something, and then once you read, you have to get these values through these analog pins. So those are the 6 analog pins to get the sensor inputs. And we have the power pins to provide the power actually. In this one, you can see there are 5 volts and 3.3 volts and the ground line. And again, the reset is this one. So this is a reset button. Now here you can see we can give the power 3 volts or 5 volts and again 9 volts, like, and the ground lines are also there. So here also you can see the ground is there. So like we have the different power pins which you can use based on your requirements. And the reset buttons, if you want to reset, normally we use the reset button to restart your programs. Or maybe when you are making some testing and debugging, which is very important. When you press that, current of programs will be stops. And there are two functions actually stop in your Arduino program. We'll discuss them: is setup function and the loop. So setup function runs again, and the loop function will start from the beginning. So like to do that one, you can use this reset button. And there's a crystal oscillator as shown in here. And you can see this crystal oscillator shown here, which is normally used to generate the clock signals. To manage the operation, we must have a clock. So like that activities you manage based on the clock, so that generally the clock's signals will be done with this crystal oscillator, which is having 16 megahertz, which can be used to synchronize other tasks together using the clocks generated by oscillator here. And we have two LEDs, TX and RX. So TX LED is running when you send the data. RX LED is running when you receive the data. So receiving and sending some data from the Arduino, or when you receive some data to the Arduino, you can see them through these two LED. That is there, as you can see in here, we have those two LED as shown in the middle of the device. We have these two LEDs. By using this, you can monitor whether you are receiving some data or whether you are sending some data. And again, there is a on LED actually, which will indicate whether power is received. The on LED will be running whenever power is received to your Arduino. Whenever USB cable is connected or external power is given, this light will indicate, or this LED will be indicated. You can see the power LED is there. So that will show you whether power has received or not. In addition to that, there's a built-in LED which is connected to pin 13 actually. Normally that LED can be used to make some testing. When you are developing Arduino programs for the testing and debugging, you can use that LED as shown this simple program code. So initially the pin number 13 is initialized for this output operation. So this is the setup function. Same setup function runs only once actually, and the loop function runs continuously. So initially pin number 13 is set for the output operation, and this digital white function write the high value to the pin number 13. In that case, the light will be on, and you will delay this one for 1000 millisecond. That means 1 second you stop it and you make it low. That means light will not be running, and wait for another 1 second. So these program codes, you should know that these are digital input output lines. You have to use the method called as a digital write, because you are writing digital things. Because other we have the analog inputs. In the analog inputs you read only, but in the digital 14 IO pins, either you can read or can write. Now this one is to write. So digital write is a method. Remember this code. I will explain later how you can make this coding related to the Arduino. At the moment, you can just try to understand the code. So we use these Arduino programs. To do the Arduino programs, you need to have the Arduino Uno board and USB cable to connect your computer and the Arduino board, because you write the program in your computer. Once you write the program, you have to upload this program to the Arduino. For that, USB cable is necessary. And your computer is necessary to run the IDE, Arduino IDE, Integrated Development Environment. Software should be installed, and breadboard is necessary to create complex circuit. We have to use a breadboard, and jumper wires are needed to connect the some of the uh, electronic devices. LED resistors, sensors are necessary to work with this Arduino. We have the Arduino IDE, which you can install in your computer so that you can easily write the program and you can compile and you can check whether they are working correctly. So basically you can install this Arduino in your computer and you can open this one Arduino IDE, and you can connect to your computer and the Arduino using the USB cables, and you can select the correct Arduino board, because there are many Arduino boards, but heavily or popular one is Arduino Uno board. So like you can select what is it and what's the communication port you are going to make the communications, and you can write the programs and you can upload that program to your Arduino board. So this IDE actually you can download if you go to this www.arduino.cc, and then you can download the software and install in your computer this IDE. So it looks like this actually. Very easily you can write the programs, and with this button you can compile or verify, and you can upload this code to the Arduino boards by connecting this Arduino with your USB cable. Like easily you can make some programming with this. So when you are going to write the programs, you need to select the which Arduino board you are using. Probably we are using this Arduino Uno board because this Arduino has many boards. So you can go to the tool and select the board, and then you can select what boards you are going to use. But mostly I use the Arduino Uno board, which is very small and very low cost. And then you have to select what is the port you are going to use to connect. For that also you can go to the tools and select the port. So it depends on the situation. You can see COM3 or COM4, COM5, one of the ports should be used to make the communication between your laptops and your microcontroller. And remember, when you are writing these programs in the Arduino, mainly there are two functions. One is a setup function, other one is a loop function. Normally, setup functions runs only once actually. So that will be executed when the Arduino is power on, or when the reset button is run, when the new program is uploaded, this setup function will be running. So through that you can set up which pin is for input operation, which pin is for the output operation, like you can set up it. After that, continuously you have to run the programs. For that, use a loop functions. So normally the setup function is to configure the pins, so start the serial communication, initialization. So those things can be done with the setup function. Loop function is the one which runs continuously until the Arduino is switched off. So yeah, you can use the loop function to read some inputs or to process some data and control some outputs, like loop is running repeatedly. For that purpose, you use the loop function. That is the one which will be running continuously. So when you're writing this Arduino Uno programs, actually all the lines that you're writing in the Arduino should be ended by semicolon. Remember, each code that you're writing with this should be ended by semicolon, and use a curly brackets to indicate the starting and the end. And the comments can be written with the double slash single line comments. Multi-line comments can be implemented using the slash, star, and star slash. Can be used for the multi-line comments, because we are now writing these codes, we need to add some comments to explain your code. Remember, this high case sensitive. Capital and simples are two different things. Therefore, when you're writing the codes, proper spelling or lowercase and uppercase are very important, because Otherwise, it doesn't work. Not like HTML like languages or Pascal like languages. Yeah, it is not case sensitive. Capital simple can be used whatever you like, but here capital simples are matters actually. You have to carefully write the programs. And you can use the variables when you're writing these programs. In that case, remember you have to define the data types as given here. Number is a variable, integer data type, value is assigned to 10 and ended by semicolons. So therefore, when you are working with these variables, variables are basically names actually to store the values in the memory. So these are the data types that you should know in the Arduino: integer, float, char, boolean, long, byte. These data types can be used when you are writing the programs, the variables. Some instance you have to use a constants where the values are not going to be changed. We know the variables are going to be changed, but the constants will not be changed. As an example, I want to keep this pin number 13 is constant. In that case, we define as LED pin as 13. So then you know this one is representing LED pins. So in that case, you can make initialize that pin number 13 for the output operations, where you can on and off this pin actually. So to make the configuration of the Arduino pins, there is a function called as a pin mode. Remember, when you're writing that pin is a simple letters, M is a capital, pin mode. In that case, you can use that what is the pin. Now, let's say I want to make the pin number 13 for output operation. Or let's say I want to make the pin number 2 for the input operations. Like you can define what to do, input to output. So then remember this input output letters should be capital letters. Just keep in mind because it is case sensitive. This is an example. Let's say we want to blink built-in LED. I told you there's a built-in LED in the pin number 13. Let's say we want to switch on and off this LED bulb that is already there in the pin number 13. So initially in this program code, you had to initialize or name the pin number 13 as constant, and then you can initialize that one for output operations. In the loop function, we can write the code. So digital write is a function. Remember, W should be capital in the digital write function. That LED pin, you make it high. High means you are sending some voltage to make it on. And delay 1000 means you delay the execution for 1 second. 1000 means actually 1000 microseconds. So it is we delay the 1 seconds and you make the LED bulb off. Low means off. And again you wait another 1 second. So this will run continuously until you power off of the Arduino board. Now again another thing is actually when you are working with this circuits, normally we use a breadboard. So basically breadboard is a reusable board which you can use to do some electrical constructions without soldering actually. So then easily you can attach different components to this one and create a experimented device. The experiments can be done with this Arduino and other electronic devices can be sensors and others can be connected to this board. So that is we call as a breadboard. You can see in this breadboard we have these outer lines that can be used to provide the power and you can connect to the ground, and you can see inner lines are connected as shown here vertically in this diagram. These inner pins are connected through these lines so that you can connect our devices through these pins, and again you can connect multiple devices and create a circuit. For that actually we use this breadboard, so without doing the we don't need to do the soldering actually. Easily you can construct the circuits. So here you can see we have these outer lines which can be used to provide the power. So plus is the one where you can get the power, and the ground line can be connected to this minus one, and the middle lines can be used, center lines can be connected as shown in the previous page. So you can see here in this one 5 volts can be connected with the positive line, ground line can be connected to the negative lines as shown here. So this is an example to connect the multiple resistors actually. So as I told you, these power lines can be connected, positive and negative lines can be connected here. And then you can see this this circuit is connected here because these lines are connected. So he is the one which will connect here. And then this line is connected. This line is connected. And then you connect with the resistor here, and these lines are connected. So therefore, this is a resistor, and again these lines are connected. And this is a resistor, and again these lines are connected. So that you can create this circuit as shown here. So either you can connect like this, or you can connect like this. So I will share these slides for you to study. Then just study this one. Actually, I will share the slides. So this practical one diagram where you can see the Arduino boards. We have the ground line and the power lines. So the power lines can be connected to the positive one, and ground line can be connected to the negative one. So that other devices can be connected to the breadboard middle to create the circuit. So this is an example how do you connect the LED bulb externally. So in that case, actually we have to use some resistors because we want to control the power that are coming to the LED bulb. That is why we have to use the resistors here. We'll discuss some examples here actually. One of the example given in the syllabus, one system is actually what we call blinker. So we want to on and off LED bulb periodically. To build that circuit, they have given the diagrams and other information. In the exam paper also some questions was there. Remember this question, actually this Arduino and again IoT based question initiated 2022 onwards actually. Previously there were very few questions from the IoT, but now recent papers we get the IoT questions as well as some other parts, maybe some intelligent agent or maybe some future technologies like different questions are connected to this. However, these questions are not difficult. You have to just understand these four practicals actually. These are first practical. Now we want to on and off the LED bulb. For this actually I have to use Arduino Uno microcontroller and one LED and 220 ohm resistor should be used because we want to drop the voltage that are coming to the LED to protect it. So LED is actually light emitting diodes. It's a semiconductor electronic components that emit lights when the electric current passes through the LED. So which will generate the light, and again we use a symbol. This notation will be used as shown this diagram. This notation is used for the LED, which consume very less power actually. Very lifetime is very long. Many colors are there, which is generally very low heat with compared to others. So in this one actually we have two leads. One is called the anode, the other one is a cathode. Normally positive line is connected to the anode, negative line is connected to the cathode, and then the larger lead is actually anode. A smaller one, shorter one is a cathode. That's how you identify which one is positive, which one is negative in the LED. So the long leg actually positive one, shorter leg is a negative one. The ground should be connected to that actually. So for that we want to connect the resistor because resistor is the one which will limit the current flowing through the LED. Otherwise you may get more current and then it will be lost or bursted. Otherwise burn out the light. So because of that we want to always connect this with the resistor. So this is the diagram for the Arduino Uno board. You can see we have the different pins. Now here is the place we connect this. Remember these other parts are already there actually. these 5 volts and everything is connected. The reset buttons they are already there. The oscillator is there. This is the place we connect actually. This one. So we use the pin number 8. Digital pin 8 will be used to send the power to on and off the light. Now this is the resistor and this is the LED bulb. So to sometimes you get more current, to drop the current level, you have a resistor here. This you have to connect the LED. So then you can program to on and off this LED. So this is the code actually. So in this code you can see there's the pin number 8. Use the pin number 8. So we set the pin number 8 and you use that one for the output operation. So then the pin number 8 is used for the output operation. This is a digital pin. So we are using that one for output operation. In the loop function, we want to provide the current. So then you make it high and delay for half a second, and you make it low off the light and delay for another half a seconds. So in that case, light will be blinking very faster, half a second, half second. So that's a very simple code. Remember, when you're writing this code, you have to use that digital write, which is actually W should be capital. So this is the diagram actually. You connect the digital, use the digital pin 8, this one, for the output operations, and you connect that to the resistor. This is a resistor and LED bulbs that is connected to the ground line. So here you have the ground line. Then the second example or experiment they have given is actually auto light. So for this one, what I'm going to do is actually we want to turn on and off the LED based on the light intensity. That means the light is dark, you want on the LED. When it is light is not dark, we want to off the LED. So that is the one we are going to use. For this actually we have to use Arduino Uno board, LED bulb and resistor and light dependent resistor. That is one which will measure the intensity of the lights. So based on that value, we want to on and off the LED bulbs. So then again, another resistor should be necessary to connect to the this resistor. What is LDR? So LDR means light dependent resistor, also known as a photoresistor. It's an analog sensor actually that will detect the intensity of the light. So then it will change the value or based on the, if it is a brighter light, resistance will be decreased. If it is a lower the light, resistance will be increased. So that is the one which is done by this LDR, or what is called the light dependent resistor. So based on the light, resistance will be increased and decreased. You can see whenever there is a high light, resistance will be decreased. But the light intensity is low, resistance will be increased. So here we have some pins. Actually, there are two terminals. They are not polarized. We can use whatever you like. And then you can use the, we have the analog inputs. You can use this analog pin to read the resistance value from these pins. So in that case, you can arrange the analog inputs, and you can use ADC to convert the analog inputs in the digital value. We have the 10-bit ADC. So that means you can go up to 0 to 1023. So then you can see when it is very high bright, you can define this digital value 800 to 1023, and darkness is defined as 0 to 150. So this is the LDR. Using that LDR, you can measure the light intensity, and then you can get that input value through the analog input, and you can convert this to digital values using the ADC, analog digital converter, and you can get the answer in between the value 0 to 1023 because it is having 10 bits ADC. Normally we can use for this one is automatic street lighting, like automatically light will be on and off in the street. So home application also can be used. This actually in many applications are there. So this is the example given in the textbooks in your LL syllabus, and here is the LED bulb which is connected the resistor through the digital pin out 8, and this is the one which will read the this is the analog input. Through that you are reading the values from the LDR. So LDR also connected with this resistor here, and through the LDR you are reading the value through the pin number 0, A0. A0 is analog input. So you can read this value through this analog input. What is the LDR outputs or sensor value? You can read it, and you can get the corresponding digital value, and accordingly you can program it. So this is a program code. You can see initially A0 is initialized to A0 is the place where you read the inputs, analog inputs you read through that, and LED pin 8 used to on and off the LED bulbs. So initially you can set the LED pin for the output operation where you can write the on the light by writing high value to this pin. In the loop function, you can see you read the LDR pin through the A0 is a analog input. You read it, and once you read it, that value you can check whether if it is less than 150. That means the darkness. It's dark. Then you can on the light by using the digital write high. If it is not the case, if it is else, you can off the LED. So that way you can simply write a program code. So this is the way you can connect the circuit. You can see pin number 8 is connected here with the pin number 8 digital pin that is used for the output operation, where you can send the high when the darkness is occurred. This is a resistor, and this is the place where you have used the LED bulb. This bulb can be on when the darkness is there. So this resistor is used to protect the LED if it is giving more current or more values. And then this is the LDR actually. So this is the LDR sensor that will be connected to the A0. As we can see, we have the analog inputs. Through that you can read the values. You can read the values to the Arduino, and the resistor is the values one which will manage it. And this is the ground level here. We can get the ground value from this one. Okay, then we go to the third one. Third one, this is behind the syllabus, is actually auto pan. So this auto pan is used to on the pan. You have a temperature sensors, and based on the room temperature, you can on the pan actually. For that purpose, use this systems practical. For that, you have the Arduino board. 9-volt DC motor is necessary, and LM35 temperature sensor. To get the temperature value, you have to use LM35 temperature sensor. And we have to have the transistors. Why we have the BCS 547 transistor? Because to run the DC motor, you need to have the more current. Then this transistor work as an amplifier to provide the more current for this DC motor. We use transistors, and again resistor is there, and diode is there, because whenever motor is off, and what happens, it generates, it just work as a generator which will create some high voltage. Then to rectify that one, diode is necessary actually to protect the your systems and the motors. We have to use the diode. So what is LM35 sensor? Remember, it's an analog temperature sensor that will measure the surrounding temperature and produces the output voltage based on the value you can convert into degree Celsius. So that is widely used analog temperature actually. It directly measures the temperature in terms of Celsius. The voltage value can be mapped into the Celsius. No need to have the extra calibrations actually. Less power consumption, like more accurate device. So here you can see we have 3 pins in this LM35 sensor. One is a voltage, we have to provide the power. Other one is a ground. And the middle one is the one which you can use to get the inputs, that is temperature value will be coming through the analog out actually. So that is the one you have to use to read the values from the sensor. So the analog input can be connected to this pin. So this is how it gets converted actually. Each voltage value is mapped into the different Celsius value. So that just by 100 multiplication, you can find out what's the temperature. So here you can see you can connect the Arduino pins 5 volt to one of the pin here and the ground. In the middle one is the one you can connect to the A0 or analog input 0 to read the temperature value through the sensor. So this way you can connect these pins to the each pin in the sensor. So this sensor has a 3 pins, LM35. So this is a program code. So this actually just to print the Celsius value. So simple program code. So you said you set the A0. A0 is we are going to use that one to the read the temperature that is coming through the sensor, and we have used the serial dot begin 9600, that is to read the data that much of speed actually, that is a bit rate actually. And then you have used the function analog read function. So this analog read function is the one which will read the value through the sensor, this function. Remember, R is capital, analog read. And this will get the analog temperature through this pin A0. You can get the analog temperature, and then you can convert that into this value, and you can multiply by 100, you can get the temperature. So based on that value, you can display what's the temperature currently there actually and delay the program for 1 second. That is very simple code to read the value from this sensor. But that is not the one we are going to do here actually. Now for practically you have the DC motor. It's an electromechanical device actually that converts a direct current, electrical energy into the rotational mechanical energy. So then why can't Arduino drive a motor directly? Remember this DC motor, normally we don't connect directly to the Arduino board. The reason is the Arduino board cannot provide the large current to this DC motor to run. So therefore we have to connect that with the what we call this transistor, because transistor will amplify the current and provide the more current for this DC motor. And again, remember, this will be connected with the, again, directly we don't connect this to the Arduino because it works as a generator when it is off. Therefore, we have to get that voltages. For that, we need to have the diodes also. That is why we don't directly connect this one to the Arduino board. So remember, DC motor, you don't connect directly to the Arduino board. One reason is power is not enough. Other reason is when it is off, it generates more work as a generator. So this is an example diagrams. Arduino boards, you can see the motor notation is use this M to indicate the DC motor, and you can connect the DC motor with actually, as I told you here, we need to connect that with the transistor here. You can see this transistor. Transistor is the one which is connected to the Arduino board, because you don't directly connect the this motor to the Arduino board. The reason is power is not enough. Therefore, you connect that through the transistors, and again it is connected through the diode actually. Should be connected diode to capture the more voltage that is generated by the motor. Otherwise, it will damage the Arduino board. So the transistor, as I mentioned to you, it's a semiconductor device that work as an electronic switch for the amplifier. In this case, it works as an amplifier because the DC motor needs more power. So in that case, to provide the more current, we use these transistors. So in that case, actually, the transistor has three pins: the base, collector, and the emitter. Sorry. So then you can connect them according to this diagram. You can see here we have the transistor, and then so this transistor. So then Arduino boards pin number 9 we connect with this, and that will give you the more current to the DC motor. And also you can see DC motor is always connected the diode. The reason is it works as a generator once it is off. In that case, you have to make protect your Arduino and the other devices. You have to use the diodes here, because motor will work as a generator once you switch it off. In that case, you have to protect your Arduino board. So the diodes, you can see diode is a semiconductor device that allows current to flow in one direction. Block the current in the opposite direction so that you can protect your device, to protect the transistor, to protect the Arduino, the absorb the reverse voltage. So to absorb the reverse voltage, you have to use this one actually. So this is the diagram with the diodes. You can see diodes have the anode and the cathode. Anode is for positive connection, negative connection is done with the ground is connected the negative one. So basically, as I told you, to protect the Arduino and the transistors, to absorb the voltage, we have to use this diode. So this is the diagram which is there in the resource book in A level. Now this is the motor. Here we have the motor, and this is the diode, and that is connected to the 9 voltage here, that voltage values here. And this is the transistor actually, which will amplify the current and send to the motor. So, and here is a LM35 sensor, which will measure the temperature, and temperature value is read through this pin, and that comes to the A0 analog input. Through that you can read the values. So this is the program code. So you can use a sensor pin A0. Through that you can read the LM35 temperature value, and motor on and off will be done with the digital pin 8. So then you set the motor pin for the output operations, and you can read the temperature value using the analog read function through the sensor pin, and then it can be calibrated to the value analog digital conversions, and then you can check the temperature value. So in that case, if the temperature is larger than 30, sorry, was disconnected. So this is the again diagram. You can see we connect that with the so here you can see this one is the LM35 sensor, and we provide the current and again the ground, and this is the one we read the value. This one is the one we read the value through the analog pins. We read the values, and we provide voltages here, and then you can see this is the transistor, and then through that you can provide the power for this motor, and this is the diode. Then the fourth one is the door alarm. So in this case, actually, we want to construct the door alarm. When the door is open, it will generate the alarm. So for this one, actually, door alarm, we need to have the Arduino boards and PC buzzer to generate the alarm output and read switch to detect the door is open and closed. For that, we use the read switch and 10 kilo ohm resistors to be used. What's read switch? Remember, read switch is the magnetic switch that opens and closes on an electric circuit when exposed to the magnetic field. So the working principle is actually there is a magnetic attraction. If there is no magnet nearby, the contact remains open. But when there is a magnet nearby, it will be connected together. So using that, you can check whether now can you hear? Can you hear me? Maybe connection issue actually here. Maybe we are going to have raining, I think. Is it clear now? Or can you hear me? Is it audible? I'm not sure why is that actually. Maybe connection issue is there still, I think, because of this rain conditions. Is it? Can you hear me now? Is it audible? Maybe. However, I'll share the recording so that you can watch this one again. So the read switch is the one which will can be used to determine whether door is open or closed. For that purpose, read switch is used. So it has two pins that can be used to connect. And piezo buzzer is actually it's an electronic output device that converts the electric signal into the sound wave. So basically, it has plus or minus, positive and negative. And you can carry the Arduino digital pins to 5 volts to one pin and the ground line to the other one. So normally digital pin 8 normally used for this piezo buzzer to generate the sound. So this is the piezo buzzer. You can just connect the positive and negatives there. And digital output can be connected to one of the pins that is there in the piezo buzzer, which will generate the sound. So this is how you can connect it actually. Now here you can see this is the read sensor actually. So this will determine whether the door is open or closed, and that sends the inputs you can get through the value here. Through this pin you can read it, and the sound can be generated through the digital output 8. We can generate the sound. So here's the code. Pin number 9 is used for the on operation. So basically that is to input to get the input actually through the sensor whether the door is open or closed, and buzzer pin actually that is used for the out operation to generate the sound. In that case, once you read the digital value, digital input 9, Through that you can find out whether the door is open or closed. If the switch state is low, that means it is open. In that case, you have to generate the sound. For that, you use a function called tone. So then one pass the pin will generate the sound. Otherwise, you can no tone. So using that code, you can program it actually. So you can have there is function called as tone, and the no tone function will be used to generate the sound. So this is the code diagram actually. So this is the read switch, which will detect whether the door is open or closed, and that is connected to pin number 9, so that you can get the value to the pin number 9. And this is the piece of buzzer that is the one that generates the sound, and you can program that to generate the sound. The last one here we have is smart light. So basically we want to on and off the light through your validated base. For that we use the Arduino. And Arduino Ethernet shield should be used to connect the internet. So Arduino Ethernet shield, remember, it's a kind of expansion board that allows Arduino boards to connect with the local area network, so internet, through the RJ45 cable. So you can attach that to the on top of the Arduino boards. Through the pins you can connect it together, and through that actually you can connect the RJ45 Ethernet cable can be connected. Through that you can connect the Arduino boards to internet. For that actually this Arduino Ethernet shield should be used. So that RJ45 boards can be connected. It supports the DC networking, and you can connect the server applications, or reliable communication can be done the Arduino board through the Arduino shield, which can be attached on top of the Arduino board. So basically, how does it work? Ethernet shield is attached to the Arduino, and then you can connect the RJ45 cable to this RJ45 port, and then you get the IP address. DHCP will buy this dynamic static IP can be used, and then you can use the IP to make the programming so that you can access to the other devices through the internet. So this is the one we have to connect. As shown here, you can see we want to connect the this is the Ethernet shield. Through this you can connect the RJ45 cable, and you have to connect that to the pins that traditional pins can be connected with these pins that are inside the Ethernet shield. And then you can connect the internet to on and off some of the pins through the internet. You can use this communication that is given by this what we call Ethernet shield. So this is how you can connect it actually. In this way, you are on and off the LED based on through the internet, and can control it actually. So that's the part I will introduce you today. And we have some past introduction on 2021 onwards. So tomorrow I will schedule another class. This is the last date where I will discuss the past there. So thank you for joining.